Okay, today what I'm going to do is show you how to draw a mechanism, but in the context of being inside an enzyme. Inside an enzyme, we have the ability to have both an acid and a base available for us to use when we do mechanisms. This is in contrast to what you've seen in organic chemistry, in which you either have to be under basic conditions or acidic conditions. Now, what's important is that the acid and the base is actually side chains of the enzyme. And so I can act as an acid or act as a base depending upon the protonation state. So what we're going to do is we're going to add the ammonia to the carbonyl. What we're going to do is convert the ammonia into a nucleophile. And then we're going to need to protonate using a proton to end up with a final product right here. Okay, and so what I would formally do is draw out what would be the acid and what would be the base. And so this component would be, I'll go back. This would be our base, and this side chain would act as an acid. Okay, and so the first part of my mechanism, this base right here, okay, this negative charge can go and accept one of the hydrogens, leaving a pair of electrons free to attack. And this nucleophile is going to attack at a partial positive, which is the carbonyl, because the carbon is partially positive, the oxygen is partially negative because of the electronegativity difference. Now when that attack happens, we have 5 bonds to carbon. That arrow represents 5 bonds to carbon. And so what I can do now is take this pair of electrons here and pick up the proton. Now what's really happening is, for a moment in time, the electron pair is going to sit onto the oxygen. Since the oxygen is electronegative, it's fine. It can accept that pair of electrons, and then it will go and pick up the proton. But I show it all as one movement. And so we then have the nitrogen attached to the carbon, which is right here, and this ketone now becomes the hydroxide, and the hydrogen right here is the hydrogen right there. Now, in most organic mechanisms within the enzyme, we're not going to draw out which particular amino acid is the acid and which is the base. Much more often, I'm going to represent the base as this entity here. Base that has a lone pair of electrons that's able to abstract, and instead of showing the entire acid, we're going to show hydrogen as being the acid. So in more simple terms, which is more often what we'll see, is the base. Remember, this is an amino acid. Side chain will extract that proton. This pair of electrons will attack at the carbonyl. I will kick up onto the oxygen, pick up the proton, but then I will show this as a single movement, yielding the reaction. And so we have, in this case, a nucleophilic attack at a carbonyl using an acid and base inside the enzyme at the same time.